Hello, sir. So, at this moment, I will be discussing about the laboratory activity 7, convolution of analog signals. So, these are the objectives for these laboratories to perform analog signals and to compare the output of Python's built-in convolution function with manual convolution. Okay, so let's start this. So, here's the code for the laboratory 7. So as you can see here, I've imported the numpy as np and also the matplotlib.pyplot as plt. And here is the from scipy that signal to import convolve. So first one is that I've assigned a variable which is this the t is equal to np that line space quantity of -5 5 and 1000. So what does this mean? So it means that there will be a range of numbers from -5 to 5 with the thousands of steps. So next is that I've defined the analog signals, the x and the h. So the x is equal to np that where quantity of t is greater than or equal to 0 and t is less than or equal to 2. And so that's actually the rectangular pulse width. And also the h, which is the exponential decay for t is greater than or equal to 0. So next one here is that the dt. So what does that this mean? So dt is that the time step. Okay, so it is the one who need to be scaled the distance convolution to approximate continuous convolution. So we have here that t as a function of 1, or like this is the number um, within the t of 1 and minus t quantity of 0. Next is that the y convolve x comma h mode is equal to a full. So the full means here is that um, there is a return to complete the convolution. So it wasn't the original signal. Okay, then it is multiplied with dt. Okay, so next is that the t um, convolution is equal to np that line space 2 times t of 0 comma 2 times t 1 -1, and that's the new time axis. So this one here are the definitions or how will be the waveforms presented through the Python. So here is the fixed size and the subplot. So the subplot means is that um, in simple terms is the location of where should the output will be shown. For example, here 311, so it will be shown in the top part. And the plot, also we have the label, x, y, and the grid. So here we are also here for the subplot. So the 3, 1, and 2, yes, and so it is in the middle part, and the output is labeled as exponential decay. And next for the subplot and the convolution. And finally, we have here the word for show, which means that all of this will be shown, will be presented. So let's see, let's run the code. So here's the output of the code. So as you can see here, the rectangular pulse, exponential decay, and of course the convolution. So that's all for this laboratory. Thank you.